Hi, okay, welcome to the first session of one of our grade 5 courses. Welcome. We are looking at error intervals and bounds to get us started. So first of all, what is an error interval or a bound? And it's a topic that fits in with rounding. So rather than being asked to round a number to, say, 2 decimal places or 1 decimal place, they're going to tell you that a number has already been rounded to this. And then you have to consider the range of numbers the original could have taken. Now, it's probably a lot easier to see this rather than to talk this. So let's just say I have a number. It got rounded to the nearest whole number, which was 6. So what values could my original number have taken? Now, if we consider our rounding rules, 5.5 would have rounded up to 6. 5.6, 5.7 would have rounded up to 6. In fact, any value between 5.5 would round to 6. Okay. Let's look at the highest possible value. Now, 6.5 would be rounding up. But the number before 6.5, which would be 6.4, that would definitely round towards the 6. So would 6.49. So would 6.49 and 9 and on and on and on and on it goes. Okay. I don't really want to work in a number that goes on into infinity. It's not precise or concise enough. So I'm actually going to use the 6.5, even though it technically rounds up, and use my inequalities to set up the range so that I can get away with it. And I'll show you what I mean. Okay, my number, 6, has to be greater than or equal to 5.5. So I'm reading that kind of backwards. 6 is greater than, but it can equal 5.5. And that inequality now picks up all these numbers in that range along that number line there. So I need to do something that takes me to the 6.5. So if I draw that going up to the 6.5, 6.1, 6.2, 6.25, 6.39, all those numbers, an infinite number of numbers, okay, 6 would be less than 6.5, but I'm not going to do that. I'm not going to put that equals on because then I've just said it could have equaled it. And my original number was rounded to 6, and there's no way it could have equaled 6.5 because if it did, I would have rounded up to 7. So by using the inequality symbol without the equals, it means that I can very concisely write 6.5. As long as the number is less than 6.5, so 6.499999 could be in there, then this inequality shows the range of numbers my original number could have been. And that is error intervals. That is an error interval written right there. All right, let's see it again, because the first time you see it, there's a lot of information coming your way and a lot to take in. So let's say that I have a number that's been rounded to the nearest 10, and that number is 80. What are all the possible values my number could have been before it ended up becoming 80? Now, this is the best approach so that we don't get ourselves in a muddle. I like to draw a number line that is in the way that the question's been given to us. So I've said that my number's been rounded to the nearest 10. So my number line is going to be in tens. So the number before 80 would have been 70, and the number after 80 would have been 90. That's my tens number line. Now, halfway are my rounding points, 75 and 85. It makes it really easy to identify those halfway points if we actually draw out a number line. So I would really encourage this as a method. Now all I have to do is take the endpoints. 75 would have rounded up to my number, and it could equal it. And as long as it's less than 85, it works. Now I've put n in the middle because that n is representing the value, the number that it could have been. Okay, and there is my error interval right there. Okay, we'll do one more and then you can have a go. All right, if you want to have a go now, if you think you've got the idea, then press pause and hit play when you see the question. Okay, so I am going to say that a number has been rounded to the nearest 1 decimal place, and that number is 7.2. Write down the error interval. So hit pause, have a go, press play if that's what you would like to do. If you want to see it one more time, just let the video play. Okay, so this time I'm having a 1 decimal place number line. That's what tells me the number line. So 7.2 is in the question, 7.3 comes next, 7.1 comes before. Now my halfway markers are 7.15, 7.25. So those are the end points for my error interval. Now I've literally just got to write it up. 7.15 can equal that one, and it cannot equal the higher version. There it is. That is my error interval. Now, this is quite common. I'm seeing it a lot on exam papers at the moment, but what they are doing quite kindly is the answer looks like that. So all you actually have to do is find the numbers and pop them on the dotted lines. Now we're obviously going to be setting the whole thing up, which means that we're going to be getting good practice at pulling the inequality together from scratch, which is good, because if they didn't do that and you were relying on it, you'd kind of be a little stuffed, wouldn't you? So this is important, the way that we're doing it. Okay, right, having a go this time. So a number has been rounded to the nearest 100 to give 300. Okay, so rounded to the nearest 100 to give 300. Hit pause and press play when you think you've got the answer on that one. Okay, so it is a hundreds number line because that was the rounding. So it's going to be 300, 400 and 200. Pop in that middle marker, 250, slap bang in the middle, 350, slap bang in the middle. So 250, it can equal that. I'm going to put number, and 350 is my endpoint. If you got that right, fabulous, well done. Let's do another one. Okay, clean that off. So a number is rounded to the nearest 10th to give 7.8. Write the error interval. Okay, so hit pause, have a go, and press play even when you're ready. Okay, so this may have put you off a little bit. What do they mean by the nearest 10th? Think about the word 10th and what that looks like numerically. Okay, that looks like that. A 10th is 1 decimal place. If you think about our place value, we've got 100, tens, units, got our decimal point, and then we've got our tenths. So any number in here is basically 1 decimal place. And they are likely to do this type of thing because it is at a higher level. It's at the end of a GCSE paper, or near the end. So they are likely to write it in a way that's really going to test your knowledge of our number system. So now we know it's 1 decimal place. We would do our number line. So I've got my 7.8, 7.9, 7.7, and find those middle points, 7.75, 7.85, and my error interval is that. Job done. Okay, so that's writing an error interval. Understanding the number line that we need to pull together is the first step, and then it's literally just find the middle markers. Nothing more complicated than that. Now, these numbers can also be described as lower and upper bounds. So if I had changed the question to say a number had been rounded to the nearest 10th, and that number was 7.8, what is the upper bound? That sounds like a completely different topic, but you would do the exact same thing, and the upper bound would be the bigger value that you found. That's my upper bound, which means this is my lower bound. So if I'm being asked to find a lower or an upper bound, they're actually just asking me to still do the same thing, find that error interval, but just select either the lower number or the bigger number. And that's all the bounds are, okay? So let's do a question based around the bounds, just to make sure we have followed that. So a number has been rounded to the nearest 10 to give 430. Write the upper bound. Hit pause and press play when you're ready. Okay, so nearest 10 means it's a tens number line. So there is my number line. There are my halfway points. The question is asking for the upper bound. So my upper bound is 435. All right, so it's different language, but we need to make sure that we're linking it to this same method, to the same skill, and then we will be able to get it right. Okay, one more, and then I'm going to leave you to some practice. So I'm going to say that a number has been rounded to 2 decimal places to give 5.82. What is the lower bound? So hit pause and press play when you're ready. Okay, so 2 decimal places. I can see that in the number. The next one would be 5.29 and 5.27 came in front. Didn't write that very well. Okay, the halfway mark, 5.27. Right, say 7 and write 5. My brain is ahead of me. 5.285. But technically, I didn't need to bother with that last one because I'm only looking for the lower bound. So my lower bound is 5.275. Okay, that is everything that we are going to do in this session. So you've got some practice questions. In fact, I'll leave these big in case you want to work from the screen rather than the booklet. Let's just bring that down a little bit. And what I'll do is I'll slowly scroll through this so that you can see it and read it easily. The answers will then come up, which I'll do the same, and you're literally just sort of playing and pausing and rewinding. I would strongly recommend marking as you go, so that if you make an error, you can kind of learn from that and you can take that learning into the next question. If you do it all in one go and then mark everything all in one go, you aren't giving yourself a chance to sort of develop the skills when they go wrong. So that would be a strong encouragement. So I'm going to disappear. I'm going to scroll through the bits and pieces, end the video, and then I will see you next session.